let's see if we can come up with the equations for these different functions, function A, B, C, and D. And I encourage you to pause the video right now and try it on your own. So it might jump out at you that these all look a little bit like y is equal to the square root of x, which would look something like this. And we've covered this in previous videos. Y equals the square root of x looks something like this, except what we have here, all the other things look like, at minimum, we flipped over the horizontal axis, and at least for B and D, we flipped over the horizontal and vertical axis, and in all the cases, we have shifted it. So let's think about how we do that. So let's first flip over the horizontal axis. So where we would have expected a positive y, we're now going to have a negative y. So essentially, we're just going to do y is equal to the negative square root of x to get something that looks, to get this thing. This is y is equal to the negative square root of x. So put that negative in front of the radical, we flipped it over the horizontal axis. So that is y is equal to the negative square root of x. Now let's think about how we can shift this thing to look like function A. Well, function A, there's two things about function A that are different. It's shifted to the left by 3, and it's shifted up by 1. And we've seen this in previous examples. If we want to get to A, so I could write A of x, what we could do to shift to the left by 3, we got to replace our x with x plus 3. So this is going to be negative square root of x plus 3. That shifted us to the left. And then to shift up, we just have to add a 1 right over here. So that right over there is our A of x. That is our A of x. Now let's think about B of x. And actually, maybe I should move on this side so that I can clear my little scribbles right over there. So that is our A of x. Now let's think about B of x. How is B of x different than A of x? Well, B of x starts at the same point, but it's flipped over the vertical line, x is equal to negative 3. So or another way of thinking of it is domain is different. This function's domain is this is defined for x is greater than or equal to negative 3. B is defined for x is less than or equal to negative 3. And we saw that also in the previous video. What we need to do is flip the sign of everything that's under the radical. So B of x is going to be equal to the negative square root of, and going from A of x to B of x, we're going to flip the sign of everything under the radical. So it's a negative x plus 3. And then once again, we have the plus 1 right over there. Now, to go from B of x to D of x is reasonably straightforward. We just have to change how it's shifted. D is shifted relative to the original function, is shifted up by 3 and to the left by 1. So D of x is going to look very similar to B of x, except it's shifting. Its shifting is going to be different. So let me just write the part that is going to be very similar to D of x. It's negative x plus something and then plus something. D of x has been shifted relative to square root of x to the left by 1. So this is going to be x plus 1, and it is shifted up by 3, so it's going to be plus 3, just like that. And then finally, C of x is just like D of x, except everything under the radical has to have its sign flipped. So it is going to be negative square root of x plus 1 plus 3. Another way to think about it, if you wanted to go from A of x to C of x, they look very much the same, except their shifting is different. C of x is shifted up by 3 instead of 1, so that's that difference, and shifted to the left relative to the square root of x by 1 instead of 3. So that's why we have x plus 1 instead of x plus 3. The one thing I always want to stress, it's very intuitive that changing this value, if you make this larger, you're going to shift it up. If you make it smaller, you're going to shift it down. But it's a little counterintuitive that when you make this value larger, you're shifting more to the left, and when you make this value smaller or even negative, you start shifting more to the right. And the key, we go into this in some depth in the previous video where we kind of start talking about all of this, but it's just to think about, especially relative to square root of x, when you think about just y is equal to square root of x, what makes y equal 0? What has to happen under the radical for us to be kind of at the starting point right over here? Well, everything under the radical has to be equal to 0. And so you could think about that same thing over here. To be at this starting point, everything under our radical has to be equal to 0. When does everything under our radical equal 0? At x equal -1. Well, if everything under the radical was x plus 1. So I encourage you to think about that as deeply as you can and to play around with things. And then hopefully it'll start making a little bit of sense.